Hello, wishing you a great day. Welcome to Savita Dental Lecturecast in Biochemistry. Today we'll be discussing about the topic triglycerides. Triglycerides or triacylglycerides are the common names. Triglycerides are defined as esters of glycerol with fatty acids, and simple lipids, that is fats and oils, or triglycerides, are widely distributed in both plants and animals. The characters: they are insoluble in water, nonpolar in nature, commonly known as neutral fats. The next we'll be seeing about the functions or the storage of fats. There are two functions. The first one is fats are used as stored fuels. As triglycerides are the most abundant group of lipids, they are primarily function as fuel reservoirs. And the next one is fats primarily occur in adipose tissues. In adipocytes of adipose tissues are found commonly in subcutaneous layer and abdominal cavity. They are specialized for storage of triacylglycerols. Next, we'll be moving to the structure of acylglycerols. There are totally 3 acylglycerols. First is monoacylglycerols, diacylglycerols, triacylglycerols. In this, the first, second, third carbon molecules of fatty acid esterified is to the molecule of glycerols. As mono is first carbon, di is second carbon, and tri is the third carbon. Next, triacylglycerols or triglycerides are classified into two types. First one is the simple triglycerols and mixed triacylglycerols. And the simple triglycerols are defined or contain same types of fatty acid residues at all the 3 carbons, and mixed triacylglycerols contain 2 or 3 different types of fatty acid residues. In the mixed triacylglycerols, carbon 1 is attached to saturated fatty acid and carbon 2 is attached to the unsaturated fatty acid, and carbon 3 are either both saturated and unsaturated. So now we'll be seeing about few important properties of triacylglycerols. There are totally 5 types. The first one is hydrolysis, saponification, rancidity, lipid peroxidation, and antioxidants. The first one is hydrolysis. Triacylglycerols undergoes enzymatic hydrolysis to liberate free fatty acids and glycerols. This process of hydrolysis is catalyzed by lipase. The lipase enzyme is important for digestion of fat in gastrointestinal tract and fat mobilization from adipose tissues. The next property is saponification. Saponification is a soap formation. You can take it as an idea in your mind. The formation is the hydrolysis of triglycerides by an alkyl group gives glycerol plus an soap. The next one is rancidity. The rancidity term represents the fats and salts resulting in an unpleasant taste. The fats containing unsaturated fatty acids are more susceptible to rancidity. There are 2 types of rancidities. One is hydrolytic rancidity and oxidative rancidity. Hydrolytic rancidity defines the partial hydrolysis of triacylglycerol by bacterial enzyme, and oxidative rancidity is defined as oxidation of unsaturated fatty acids. The next one is antioxidants. Antioxidant is defined nothing but it scavenges the free radicals. Here, it prevents the occurrence of oxidative rancidity. The examples of antioxidants are rich in vitamin E, tocopherols, gallic acid, and alpha-naphthol, and vitamin C is also a very rich antioxidant, as citrus fruits is also important. And next is the lipid peroxidation. Lipid peroxidation undergoes an oxidation to convert into peroxidase and free radicals. Free radicals is nothing but radicals or the singlet molecules that has been accumulated in our body. These free radicals may damage the tissues, can cause inflammation, diseases, atherosclerosis, metabolic dysfunction, cancers, and even cardiovascular diseases. Next, we'll be moving on to the test to check the purity of fats and oils. There are 4 types of testers: the iodine number, saponification number, acid number, and RM number or Richard mist. The first one is iodine number. This is defined as grams of iodine absorbed by 100 grams of fats. They are used to know the relative unsaturated fatty acids. The next one is saponification number. This is defined as milligram of potassium hydroxide required to hydrolysis 1 gram of fat or oil, and this is used to measure the average molecular size of fatty acid present. And the examples of saponification number that should be present in human fat is around 195 to 200, and in butter 230 to 240, and in coconut is 250 to 260. Next is RM number or RM. It defines as the number of a milliliter of 0.1 N potassium hydroxide required to the complete neutralization the soluble volatile fatty acid distilled from 5 gram fats. This is used for the testing the purity of butter, since the butter contains a good concentration of volatile fatty acids. Next is acid number. This is defined as a number of milligram of potassium hydroxide required to completely neutralize the free fatty acid present in 1 gram fat or oil. And this acid number increases in a condition when oil is decomposed due to chemical bacterial contamination. When these chemical contamination of oil causes, this yields a free fatty acid, and this will increase the acid number in the oil, and they are very unsafe for human consumption. Thank you.